I'm feeling good about this because I think I've actually understood how this is working, or how this should work. No. Damn. If you've been here before, you know the drill. It's time for another LeetCode session. And if this is your first time here, I do these mostly every other week. And what we do is I take 2 completely random LeetCode questions and do them on the fly. So you see my raw thought process and all the mistakes I make and things I try. So without further ado, let's get into it. Random 1. Oh, we got an easy one for our first one. All right. Find center of star graph. There is an undirected star graph consisting of n nodes labeled from 1 to n. A star graph is a graph where there is one center node and exactly n-1 edges that connect the center node with every other node. You're given a 2D integer array edges. Indicates that there's an edge between the nodes u and v. Return the center of the given star graph. Okay, so we have an edge list for representation of the graph. And what we want to do is, okay, so every single node is going to be connected only to the center. Is that right? There's one center node and exactly n-1 edges that connect the center node with every other node. Okay, so there is exactly n-1 edges. Okay, so we only need to look at 2 edges, the first 2, and whichever node appears in both is the center node. Am I right? That seems to be correct. Yeah, this is like insanely easy. Okay, maybe I shouldn't say that. It might not be easy to everyone. Okay, so first 2 edges, find the shared node. Let's say 1 in edges 0, turn this. Otherwise, return, edges 1, 0. So the first element of the second list is in here. Return that one. Otherwise, return the second one. That's what it's going to have to be. Are there any edge cases where that doesn't happen? I don't think so. Let's see if it works. Oh, wait, typo. Okay, that is correct. Let's see. Is it correct? Oh, there we go. Yep, that is the correct answer. Okay, that has got to be a record for the shortest LeetCode with me problem that we have done so far. Wow. Off to a strong start, I see. Okay, let's do another one, random. Find indices with index and value difference 2. You are given a 0-indexed integer array nums having length n, an integer index difference, and an integer value difference. Your task is to find 2 indices I and j, both in the range 0 and -1, that satisfy the following conditions. 2 indices that are within the range of nums, where the difference between I and j is greater than or equal to is at least the index difference, and the difference between the numbers is at least the value difference. Return an integer array answer where answer is ij if there are 2 such indices, and -1, -1 otherwise. If there are multiple choices for the 2 indices, return any of them. So we want them to be big, and we want the difference to be big. Okay. The easiest would be if this was a sorted array, but I don't think we have such luck because we cannot sort it because the indices do matter. Now, what is the index difference and value difference potentially? Okay, it could be 0. I'm thinking because we need to find 2 indices, that is an indication that this could be solved with 2 pointers. Now the question is, should we start from opposite ends or should we start together? We shouldn't start together because we should start at least at the difference of index difference. Can the index difference be greater than the length of the nums? It could be. It never says that it's not. So let's test that edge case first. The difference between the index is greater than the length of the nums. Okay, so I minus j. So let's say we have like this. We have length is 4. The difference between 0, 1 to 3 minus 0 is 3. So it cannot be greater than nums minus 1. Right, so that's our edge case. Otherwise, let's have the 2 pointers start. So for example, index difference 2, we start at 5 and 4. The value difference is 1. We move to 1 and 1. The value difference is 0. So then we go back and we increase the index difference. Okay, so I think we do need a loop. We can't completely just have a one pass, but we can have a loop where we start with the minimal index difference between the 2 pointers and move them together. And then in every loop, we increase it by 1 until we can no longer increase it. So we start with index difference and we end with, so we can do 5, 4, and then we can do 5, 1. In this case, the maximum index difference is 3 minus 0, so 3, which is len nums minus 1. Okay, so that is our outer loop of differing our index differences, and then that's going to be our second pointer, and then our first pointer is going to be just from 0 to our current index difference. No, our length of our nums minus 1 minus our current index difference, I think, right? I love command slash. When working with different languages, I'd never have to remember how to actually make a comment. Okay, so this is going to be our second pointer, and this one is going to be our first pointer. So our first pointer is going to start at 0, and then let's say our index difference is 2. So it's going to stop, it should stop at 1. 4 minus 1 minus 2, so 4 minus 3, so 1. Yeah, perfect. Okay. Then we go if the I minus nums j and the absolute value of the difference of those is greater than or equal to value difference, then we return ji. And then at the end, if we couldn't find anything, we return that. Should be 0, 3. Okay, for this one, it's 0, 0. For this one, the answer is we can't. So why for this one did it not work? So this is 5, 1, 4. This was the example. We shouldn't have hit that. Okay, then for I in range 2 to 3. I think it's the range. It's the fact that the range actually ends 1 before that. So let's actually get rid of minus 1. There we go. Ranges always trip me up every single time. All right, that is incorrect. So what did I do? I did 1, 2, with an index difference is 1. It should be 2. So what happened here? How did we end up looking at something that is not a big enough index difference? Because that shouldn't happen. So for I in range 2 to 5, so 2, 3, and 4. So that means the second pointer could be 2, 3, or 4. And then the first pointer can be, I don't think we're actually doing this right. So this is going to be the index difference, not pointer 2. This is difference. This is pointer 1, pointer 1, pointer 2, pointer 1, pointer 2. Yeah, our indexing was completely wrong. Oh, yes. Yeah, diff. There we go. Okay. All right, time limit exceeded. So does that mean that we did not use the correct approach? So what I'm noticing is that these are all 5-digit numbers, and this value difference is huge. So maybe we could have an edge case catcher where we say that if, okay, I wonder if this is going to impact the performance greatly, but if we say if the max of nums minus the min of nums is less than value difference, then we also can never find anything, right? So let's see if that actually helps anything, because in this case it will catch it, I think, but in other cases it might just slow it down. Okay, so again, how can we improve this? Look at the topics. Okay, array, 2 pointers. Okay, so we do have a correct approach, or we did pick the right pattern to use. Let's take a look. Okay, for each diff, okay, so for each thing that we have that we're calling diff at this point, keep indices j1 in the range 0, I minus index difference, such that nums j1 and nums j2, the minimum and maximum values in the index range. Wait, so this is more of a sliding window thing? Okay, so clearly we can't do O of n squared, nested for loops. So what can we do instead? How can we get the same result with less information? No, I did not know that was a shortcut. Okay, I guess command return does a submit. Did not know that. Okay, so I think this is still a good for loop to have. So we go from range index difference. So for example, here 2, from 2 to here. And then what do we need to have just that. I think, what if we had like a sort of like a sliding window approach in which when we start here, it's the difference between 5 and 4. We could store something in like the minimum and the maximum, because the difference between the minimum and the maximum element is going to be our biggest value difference, and we want the value difference to be bigger than something. But we also want to keep track of the indices, so maybe we could keep track of the indices of the smallest and largest values. So in other words, for example, when we start here, so we have a min index and we have a max index, right? So our min index is going to be 1, and then our max index here currently is going to be 0, right? And then we move, okay, yes. So we start with kind of a sliding window of that, and then we keep adding, we start with, and then we keep adding one more and one more and one more. So like, if we pretend this was longer. So we start like this, because that is our minimum index difference is 2, so between 5 and 4. Our current minimum index is 1, and our max index is 0. That it does not have a difference of 1, so we expand. We have another index now of, like, instead of 1, it's now at 2, 3, and between 5 and 1, it's bigger than value difference, and that's our answer. Would that actually work? I think that would actually work, yeah. And then if we don't, we continue expanding until we find the differences that have the appropriate index difference and the appropriate value difference. Okay, so first we want to create the first window, right? Which is create initial indices, where, well, at first they're going to be, the min and the max are both going to be just at 0 when we first, and then we will go from 0 to the index difference, right? So the first one to be this big, so we go from 0 to 1, 2, the index difference is 2, so we actually want to go index difference plus 1, I think. Although, no, we want to start here, right? So we'll just go, we'll go to index difference, and then we go if nums I is greater than nums max I is I, and then same thing for mini, or min I is less than or equal to, actually, yes, that was a key thing that we did discover, is that we want it to be less than or equal to, although that might be good in some cases and then not good in other cases. But we'll just try it this way, and then if it doesn't work, we can return to this part. So indices, okay, now we're able to start here, right? So we have that, and then we start at 0, 1, wait, no. So we've gone through these two. Okay, let's trace this for a second. So for I in range 0, okay, so 0 equals 0, 0 equals 0, okay. We can actually start at 1, I think. Yeah, because that 0 is just redundant. Okay, so range, so 1 is, if nums 1 is greater than nums max I, it's not. Okay, so max I is still 0, and then if max I is 0, and then min I, if nums I is less than 5, it is now max I is at 1, and then we've gone from 1 to 2. That is where we stop. Okay, so for diff in range, okay, so now we go the difference. We'll just rename that I as well. Why not? Okay, so for I in range, okay, now we start from here, and then we go to the end, checking the mini and the maxi, same as before, except now we also check if the difference between the indices is appropriate and the difference between the values is appropriate, we return. So, and I minus min I is greater than equal to value difference, then we return, well, let's see, I max I, because it says it doesn't matter which order. Okay, let's see if that works. First off, with our test results. Okay, so that does work in our test cases. Let's see if it works in our submission. Wrong answer. Well, that's better than time limit exceeded, so we can work with that. See, wrong answer means we have maybe a typo or a logic error somewhere, where the time limit is exceeded. usually means we use the entirely wrong approach and we kind of have to start from scratch. So I much prefer saying wrong answer. So we are saying we don't have an answer when we actually do. So what's happening here? Let's do a dry run for this test case. So we start with 0, 0. We start with in range 1, 2. So for just this one, is it greater than? No, it's not greater than that. It's not greater than 2. Is 0 less than or equal to 2? Yes. So we now update this one. Actually, it would be easier if we do it in the same order. Yeah, so we update that one. And then we now go to our index difference. So index difference is 4. Okay, so we start with 2. So is 9 greater than 2? Yes. So we change that. Is 9 less than 0? It is not. So we actually don't need the max and the min. Yeah, because it could be between 2 and 9 and it would have been fine. But we are updating it to only have the min and the max. Okay, so our problem is that we're comparing the minimum and the maximum, and that is not the correct approach at all. However, a different way we can think about this is that we actually go through every single one and its biggest value difference oh, yes. Okay, this is all clicking into place now. For every value, or for every num that we check, its biggest value difference is going to be either with the previous maximum or the previous minimum. And we can go ahead and only check at least value difference before it for the minimum and maximum to ensure it satisfies the index difference. So what we actually want to do is we want to have something like, we start at 9 because that is, okay, let's say here, and then index difference is 2, so we start at 2 because because 9 is the second index that we can have, or to put it less confusingly, 9 is the first right index that we can have, and then because then 2 will be the left index. Now, when we look back 2, because that is the maximum index, what is the maximum and what is the minimum we can have? The maximum is at 0 and the minimum is at 0. The maximum is 2 and the minimum is 2. So the biggest difference between 9 and something before it is going to be either 2 or 2. If that is a big enough difference according to value difference, then we can return that. Okay, so let me just start from scratch. Start with index difference. Okay, so that's our I. Okay, and then max and min is 0. Okay, so if nums I minus nums max I. Okay, so maximum, let's say absolute value of those two. And then we will also check min I. So if the absolute absolute difference, so that if the difference between those two is greater than value difference, except it's not at I, it's at I minus index difference. No, it's not. So if it's 9 is less than, okay, the difference between 9 and 2 is greater than or equal to value difference, or the difference between 2 and 9 and 2 is greater than or equal to value difference, then we return I max I or return I min I. And then we want to update the kind of like prefix something for the next iteration by saying if I is greater than or equal to, or it doesn't have to be equal to, actually. We'll say if I is greater than max I, then, no, if nums at I is greater than nums at max I, then max I is going to now be I, and then we do the same thing for min. And I don't think it matters too much here whether it's greater than or equal to or just greater than. Let's see if that works. Okay, and then let's just use this test case real quick. Okay, so that test case does work. Okay, all right. I'm feeling good about this because I think I've actually understood how this is working or how this should work. No, damn. Okay, so 4, 3 is not a good difference. Shoot. We are never using index difference here. Hold on. So we are now adding 9, but we never added 0. So before we do that, we actually should add minus index difference plus 1. I think it's I minus index and plus, I think that's what we need to add. And then let's add this test case as well. Yeah. I'm not paying for it, no matter how much you want me to. Okay, so that still doesn't work because it still gives us 4, 3. Why is it giving us 4, 3? Oh, we never updated this. There we go. Okay. Feeling confident now. Okay, there we go. It's accepted. Now, we did have memory. It's okay. It's one of those things that could be difference of just resubmitting and then it'll do it. Here, on the other hand, some are getting like almost half my runtime, but let me just see if it's also a fluke. Okay, so still 51. Yeah, so that's not a fluke. Okay, so it's clearly there's something about memory that we're doing. It's not great. Okay, so, or not memory. Memory's fine, runtime. I think it's the fact that we're doing this, and especially with big arrays, this is not going to be great. So I think we should just keep this edge case. Because that one, the second one that we just deleted, was more of an optimization that we tried to do. So let's see. So that's already not happening. How did we not get this? So the index difference is 0, value difference is 1. Index difference is greater than the length of nums minus 1. Index difference be 0, 0. Or, okay, we can't have this because there has to be a value difference. Or the length is, what's the shortest length we can have according to the, so it has to be at least 1. So if it is 1 and value difference is not equal to 0, it's not going to work. Okay, this again doesn't work. And why does it not work? Because we have a value difference. Okay, so we go list index summary. So nums I, so let's say, because index difference, so 0. If 0 minus 0 plus 1, that's 1. If 1 minus 0 plus 1, so that's 2. No can do. So do we just not do that for the last one? Let's see. If is less than the length of nums, I think that will fix it. I always hate wrestling with arrays, making the indices do what I actually want. It's still out of range. Does it have to be plus 1? There's probably a more intelligent way. Oh, there we go. Okay. That is worse runtime. That is worse runtime. Why is it worse runtime? Why? Let's see. Okay, so they are also storing the number as well as the ID or index. They're also not taking the edge case. So what happens if we don't take the edge case? It still works. Okay, so I think in our new approach, we know it auto catches the edge case. But no, I was saying there's a more intelligent way to solve LeetCode problems than just changing random things about the indices and hoping it works. Okay, it's not completely random, but at this point, I mean, we have an accepted solution. And at this point, it's a matter of trying to figure out, like, what's the better, more optimal approach to this. Let me take a look at, like, some of the post solutions. Okay, so they're doing this whole part beforehand. So I did notice that this is slowed us down quite significantly, and the way they get around it here is by doing this actually beforehand, because here we have a +1 and a +1, but if we do it at the beginning before the actual run, we can actually just use the plain I value, and it will automatically already have caught that it's not too long, because it's like we're pre-doing the thing for the next round, but then we don't want to do it if there is no next round. So if we just do it at the beginning of this round, then that does it for us automatically. Yeah, so let's see if that helps our runtime. Okay, that did help pretty good. I mean, went from 51 to 47, but we did that. one extra if, well, it's taking up quite a bit. Let me see if we can get it down even more. No, okay. So how are we getting 30 seconds? Is it simply the lookups that are taking so long? The lookups shouldn't take that long. How about the fact that they're not using any absolutes? We're using absolutes. So let's think about this. If it really, I think what we can do is instead of doing the absolute, we can just figure out which way to not make this negative. Okay, so if the number is bigger than the maximum, then the biggest difference isn't going to be between it and the maximum. However, if it's smaller than the maximum, then it might be useful and this will be not negative. And same idea here. If the minimum is useful to us, then this will be bigger than the minimum, right? Yes. Okay. All right, there you go. That shaved down even more. Okay, well, I'm pretty happy with that result. All right, well, that is a wrap for today's LeetCode session. As always, let me know how you would have solved these down in the comments. And if you're new here, I'm a computer science student sharing my journey to becoming a software engineer here on this channel. I do these LeetCode with me sessions every other week, and then otherwise, I'm just sharing what I'm working on, cool projects, things like that. So if that sounds interesting, feel free to subscribe and stick around.